Hey all, so today I'll be doing the 2024 Specialist Maths exam, section B. So let's get started without further ado. Let's see how tough it is. Okay, so consider the function with the rule this, sketch the graph of this on the axis below, label the vertical asymptotes with the equations and label the stationary points with their coordinates. Okay, so in that case, let's define the function on CAS. So define f of x is equals to x to the power of 4 minus x squared plus 1 divided by 1 minus x squared. Okay, so control I2 fx. Alright, so it will have vertical asymptote, it seems like at 1 and -1, and there will be an oblique asymptote as well, which let's find out what the oblique asymptote is. So to find out what the oblique asymptote is, you just have to use the function called profrac, so P-R-O-P-F-R-A-C, and f of x, comma x. So this is the actual function itself, and whatever the term here, whatever is the term here, this is your oblique asymptote. So in our case, our oblique asymptote is this. So let's quickly plot the negative graph, so negative x squared. Okay, so as you can see that it is the oblique asymptote, right? So that's our graph done and dusted. And also we have to label the stationary point. So let's find the derivative as well. So define df of x, oh, not typing, okay. Define df of x is equals to menu for 1 x f of x. Okay, solve d of x is equals to 0. Okay, so these are our x coordinates of the stationary point, so let's substitute them in. So negative, so maybe I'll just, okay, -3 and probably symmetric, so this should be -3 as well. There we go. What is our f of 0? 1. Okay, so we have all of our necessary information needed, so let's plot this now. Okay, so let's start off with doing the vertical asymptotes. So that, then that, x is equals to 1, x equals to -1. Now we have to remove and make it dotted line, so maybe I'll plot the parabola first as well. So -1 and 1 and -2 and 4, and then here and then here. So these are just the coordinates of the parabola that I am going to plot in here. Okay, so let's see how good I am with this. Okay, so far pretty decent. Okay, this will do. Alright, so let's now make everything a dotted line because that's how asymptotes are. Alright. Okay, okay, okay. Maybe start here. Okay, that should be all good. Okay, and same with the vertical stuff. That. Okay, that should be all good. Now, our shape was like this, so that. Okay, and maybe I just have to redraw just a tiny bit here. Guess this will do. So 0 and 1. And our other one was square root of 2 and -3. So somewhere, so square root of 2 is like 1.41. So it should be somewhere around here, I believe. 1, 2, 3, 4, 5. Yeah, should be somewhere around there. Okay. Like that. This is our turning point, so that will be root 2 comma -3. The other one would be here somewhere as well, so somewhere around these lines. Actually no, it should be like here. Okay, Okay, this will do. So negative square root of 2 and minus 3. Okay, I think this is the graph here. Oh, I forgot to label y equals to negative x squared. And yeah, these are labeled. Okay, so that should be it for graphing, I believe. Yep. Okay, next question. The region bounded by the graph y equals to f of x and the lines y equals to 1 and y equals to 6 is rotated about the y-axis to form a solid of revolution. Write down a definite integral involving only the variable y that when evaluated will give the volume of this solid grid. Okay. So in that case, we know that volume is equals to pi times a to b x squared dy. If you want to find the rotation about the y-axis, it's going to be x squared, right? So let's find what x squared is on CAS. Alright, so now if I were to go back to the prop frac, there you go. So we already have x squared separated for us. So what I'm going to do is I'm going to call x squared is equals to a, and I'm going to say that solve y equals to this, comma a. Okay, so these are our solutions. So we'll take the positive root for this. Okay, so positive root, and now we just copy it down. So maybe I have to, okay, so volume is equals to, we are changing from 1 to 6, right? And then we just copy the whole thing down. So square root of, okay, square root of y squared plus 2y minus 3 minus y plus 1 divided by 2 and dy. Okay, and find the volume of the solid correct to 1 decimal place. Okay, so in that case, so we just have to integrate this. So menu for 3, well, 1 to 6 times by pi, of course. Okay, we'll select that, put that here, dy. So our volume is 11.2. 11.2 units cubed. Okay. Now consider the function g with the rule g of x, where b can be all real numbers. For what value of b will the graph of g have no asymptotes? Okay, let's define g first. So define g of x is equals to x to the power of 4 plus b divided by 1 minus x squared. And yep, okay. So for it to have no asymptote, what if I do prop frac? Okay. So for it to have no asymptote, I feel like if we put b equals to 0 here, no, actually not b equals to 0, what am I saying? Maybe b equals to -1 just by looking at this function, because if I put b equals to -1, yeah, there you go, it just becomes a parabola, and that doesn't have any asymptotes. What happens? So g of x, comma, b equals to -1. Yeah, I think that would make the most sense to put b equals to -1, because I just use prop frac. Currently our oblique asymptote is this, and we have two vertical asymptote, which is positive and -1. So if I just make the whole term 0, that means the only thing that remains is this over here, right? Which is simple quadratic. So in that case, I think b equals to -1 would do the job here. So let me just quickly plot this. G of x create a slider for b, and if I were to put b equals to -1, yeah, there you go. So it just becomes a parabola. Okay, so just I think by inspection I can say that yeah, b is going to be -1 for this. So let's remove that, and b would now be defined. So we'll delete the variable b. So menu 1 3 would help you delete any variable. There you go. So now b is undefined. Okay, so let's write this down. So b is equals to -1. Okay, the gradient function of g is given by this. Okay, for what values of b will the graph of g exactly have 1 stationary point, 3 stationary points, and 5 stationary points? Okay, so let's differentiate g. So define dg of x is equals to menu for 1 g of x. Okay, so in that case our dg of x is that. Okay, so solve dg of x is equals to 0, x. Okay, so how many solutions do we have so far? So 2, 3, 4, and 5. Okay, so for it to have just one stationary point, I guess x equals to 0 is one confirmed stationary point regardless of what the value of b is. So we have to pretty much make the rest of them kind of invalid, I would say. Like either make them 0 or make them undefined. So let's try solving these for 0. So that is equals to 0 comma b. Okay, so this can't be 0. What happens if I put the other one? Okay, so I mean, if any one of them can't be 0, then I guess we can't put b such that the solutions become 0, because it has to work for every solution, not just one. So in that case, we just have to make all of this undefined. So there is this square root of this term which is common in other solutions as well. I can scroll back. Yeah, so square root of b plus 1 is common in every. So we just have to solve for when b plus 1 is less than 0 to make every other solution undefined and only have x equals to 0 as our solution, right? Yeah, so solve that is less than 0 comma b. Okay, maybe what if I remove the square root? B plus 1. Okay, there we go. So as long as b is less than -1, we should only have one solution. So if I put Control Z. So if I put dg of x, and if I put b equals to -2, solve that equals to 0. There. Okay. So b is less than -1 should be our answer for this. So b belongs to -infinity all the way to -1. 3 stationary points. Okay, so what are our stationary points again? Alright, so we have 5 stationary points in total. And we have to have 3 defined. So basically, this will always be a solution. So that's 1 already. And then we have to have these 4 either equal to each other, like one of them, like this solution is equal to that solution, or this solution is equal to this solution, and stuff like that. Or two of these solutions are equal to 0. Is when we could have 3 solutions for this. I guess maybe what we can do is maybe we can try for solving for what the next question, which is having 5 stationary points, and then we can just restrict the other values, because if we have already the value for 1 stationary point that we already solved. If you can solve for 5 stationary points, that means the remaining one should be like the answer for this, right? The answer for 3 stationary points, if that. So in that case, if I want to have 5 stationary points, that means all of this must be different, basically. So we already have one of this here, so x equals to 0, as I said, will always be a solution. And we need to have all of these 4 as different solutions. Wait, but hold on. Look, this is negative and this is positive. So both of these are same terms, same magnitudes, but with different sign. What about this? Okay, so same magnitude. Wait, yeah, same magnitude, but different sign. So that means as long as whatever is inside the square root, like whatever is inside the big square root is greater than 0, or is basically not undefined, we will have 5 different solutions then. Pretty sure. Okay, let me see the other one. Yeah, so if this is greater than 0, this is greater than 0, this is greater than 0. Yeah, so we have to have this one greater than 0 and this one greater than 0, because that sums up all of what we need. Okay, so that's not too bad. So in that case, what I can do is, let's solve for this. Is greater than 0, comma b. Okay, and solve for this is greater than 0, comma b. Wait, why is it greater than or equal to? I don't think I kept equal to there. Okay. Right. Okay, so we have to find the intersection of these two, basically. So intersection of this solution and this solution, basically. I mean, it's pretty obvious. So one is saying b is greater than -1, and the other one is saying b is between -1 and 0. So our answer should be b equals to... Yeah, this should be our domain for b if we want to have 5 stationary points. So what happens if I do b equals to -1? Can I get 3? Okay, what if I do b equals to -0.9? Okay, so I get 1, 2, 3, 4, and 5. So I guess when b equals to -1, yeah, okay, I guess when b equals to -1, this would become 0. Yeah, all of this would basically become 0. Like, what I mean 0 is like this one, basically. All of this will become 0. Like these terms inside the square root will become 0. So we basically want this to be greater than 0 and this to be greater than 0, like I've said here. So in that case, our answer should just exclude, like our answer should still be this, but it should just exclude the -1. So it should be negative, like b is between -1 and 0, both of them exclusive. Because yeah, if I put b equals to -1 in either of the square roots here, we'll get 0 over here, and that would just become 1, 1, and all of the other solutions will become like -1 or 1, whatever we have. Right? So in that case, I would say, yeah, so there are 2 conditions. Number 1, that this is greater than 0. We don't want it to be 0. And the other condition is that the whole thing has to be greater than 0. Okay, so cool, in that case, so you want b plus 1 is greater than 0. There we go. And then we want the whole thing, which is, or maybe I'll take this, and that greater than 0. And one more thing is that we need the other solutions as well, so we need to take into account this one. Okay, cool. So the solution of B for having five stationary points would be the intersection of all of this, basically. All of 1, 2, and 3. These three solutions. So our answer should really just be -1 less than B less than 0 for 5 stationary points. So what if I put like really random values? So let's say like, okay, do I still get 5? Yeah, okay, I do. Okay, so yeah. So for 5 stationary points, our B has to be between -1 and 0 exclusive. So that means for it to have 3 stationary points, B must be between 0 to infinity, right? Because that's the only thing that we haven't solved for. Like, that's the only B range that we haven't obtained yet. So for this one, let's draw a number line real quickly. -1 all the way to infinity. -1 all the way to infinity. And then this is our 0 point, so -1 to 0. Yeah, so the only range that we haven't obtained yet is going from 0 all the way to infinity. Okay, let's put B equals to 0 as well, just so that we are 100% sure we have to include 0. Yeah, okay, so I do get 3 solutions when B equals to 0. What if I put B equals to 99? Like, oh, okay. That is strange. Okay, so B equals to 50. Oh, no. Okay. B equals to 12. Oh, okay. B equals to 9? No. Equals to 4? No. B equals to 3? Oh, okay, I see. It's because of this. So we want the output of this. So let's solve. We want the output of this to be less than or equal to 0. So B is -1. What if I put... Okay, maybe I'll remove the square root term. Okay, so this is very confusing. So if I just want to have 3 solutions, or actually, yeah, okay, I see the problem. So basically, our 3 solutions, the domain for B from 0 to infinity is correct. Although what happens is, the reason why we get non-real result is because of these 2 solutions, right? So that means if I were to put B equals to anything positive, this entire thing will become a complex solution. including this one, all of like these both will become a complex solution, which is not what we want. So what would happen is, by setting b is between 0 and infinity, including 0, we are basically saying that omit these two solutions. Like, these two solutions won't exist. And only these three solutions would exist. So if I were to copy these down and put b equals to 3. Oh. X equals to... There you go. So yeah, if I were to put b equals to 3 or any other, big number, now all of these solutions are defined. So by making b large enough so that we can avoid, what are these? These two solutions basically. So that's the logic behind the answer. Right, okay. And for b equals to 0, for b equals to 0, so what happens when b equals to 0? B equals to 0. So for b equals to 0, we still get 3 solutions. Okay, that's why we have to include 0, and if we have b all the way to infinity, that still works. It's just that it's cancelling out these 2 solutions and keeping the other 3. Okay, good question. Alright, I hope all of this makes sense. This was pretty tricky question. Hopefully all of this made sense. Okay, let's move on to the next question. Oh, complex number. Okay, explain the relation this in the form of y equals to mx plus c, where x, y, m, c, and r. Okay, x, y, m, c belongs to r. Z is equals to this, z1 is equals to that, z2 equals to this. Okay. So we have to find a linear line based on this relationship. Cool. So we'll substitute the stuff in because this is a 2 marker, so we do have to show like a couple of working out steps. So we'll have x plus iy take away 1 plus 2i equals to x plus iy take away 4. Okay, so let's input this on calculator and see what we get. So let me make a new file. Actually, it's alright. I'll just continue on here. That doesn't matter. I was trying to make a new project. Can I? Insert a problem. Okay, there we go. So define z is equals to x plus at iy. Okay, so this is our complex number defined. So define z1 is equals to, 1 plus 2 times I. Okay, and z2 is just 4. Okay, so now to find the magnitudes of the complex number, you press menu 295 and we just simply type what we have. So it's z minus z1. Okay, we have this, and then we have menu 295 and then z minus z2. We have this. Okay, pretty alright. Now we'll equate these two to solve for y. So this is our linear equation. However, I'll copy down this as well, just to show as a working out. Okay, and then we'll write the final answer. So let's copy all of this down. So we will have x squared minus 2x plus y squared minus 4y plus 5 is equals to x squared minus 8x plus y squared plus 16. Okay, and solving for y will give us y is equals to 6x minus 11 on 4. Okay, a line segment from z1 to z2 is the diameter of a circle. The equation of the circle in the form of this, where zc is the center of the circle and r is the radius. So let's plot this real quick and see how we can find the radius and the center point. So this is our imaginary and this is our real. Okay, so we have 1 plus 2i, so 1 plus 2i somewhere here, let's say, and 4, which is here. Okay, so this is our diameter of a circle, basically. So in that case, we can do Pythagoras theorem. So this will be 1, 4, and this will be 2. So our diameter would be, diameter is equals to square root of 2 square plus 3 square, which is equal to 4 plus 3, 4 plus 9 is 13, so root 13. And our radius we know is diameter divided by 2, so radius is equals to 13 on 2. So now we have to find the center point, which is basically going to be here, or maybe here. So the x value is going to be the, between 1 and 4, so that will be 4 plus 1 divided by 2, so that's 5 on 2. Okay, so that's 5 on 2, and our y coordinate, so 2, so our height is 2 and we want midway, so 1, so 5 on 2 and 1. So our center of the circle would be that, basically. Okay, so in that case, our center would be, our equation would be z minus the center, which is 5 on 2 plus I, okay, is equal to root 13 on 2. Okay? Okay, so that should be it for this. A second circle is given by this. Sketch this circle on the Argand diagram below, labeling the imaginary axis intercepts with their values. Okay, so for this, let us quickly find the equation for this using CAS. So we already have our z defined. So menu 295. So z will take away 1 plus 2 times I, and that is equals to 4. Okay. Oh, that is equals to 2, 4. There you go. And now square the whole thing. Okay. Now we can do completing the square. So menu 35. Do that, comma x, comma y. So this is our circle, the equation of the circle, and from here it becomes pretty easy to plot. So our center will be at 1 and 2 right here. Our radius is 2 here, here, and here. So now we'll just draw a circle. It's gonna be a good circle. Okay, that. Okay, it's a bit big. Why don't I just resize it? Okay, whatever. This would work. Okay. Now what else do we have to label? We have to label the imaginary axis. So we have to label these coordinates over here. So in that case, we can see that our x is going to be 0 and we are simply solving for y values, right? So let's do that. So set x equals to 0 and solve for this, comma y. So these are our imaginary axis intercepts. So we will have 0, 0 point. Oh, it doesn't say how many decimal places. Maybe exact solutions. There we go. So 0, negative square root 1, 3, take away 2, like that. And here this would be 0 and then square root of 3 and plus 2. Okay, and maybe I should just label this as well, 1 and 0, y and 1. Okay, so that's that for this question. A ray originating at z equals to 2 minus I passes to the point negative 2 plus 3i, cutting the second circle into 2 segments. Sketch the ray on the Argand diagram provided in part C. Okay, so we have a ray that passes from 2 and negative I, so here, and cutting, and to the point negative 2 plus 3i, so minus 2 plus 3i, so somewhere here. Okay, maybe I should move this one. Okay, so it's cutting like that. Okay, and I'll remove this intercept. Alright, so this will be 2 and minus 1. Okay, so I drew that. That's good. Find the equation of the ray in the form of this. Okay, and theta is measured in radians in terms of pi. Okay, so first term is pretty easy. So argument of z take away the starting point, which is 2 minus I equals to the angle now. So this is the angle that we need to find. Okay, so in that case, I guess we could determine the gradient first. So a gradient is equals to 3, I believe, plus 1 divided by minus 2 minus 2. So that should give us minus 1. So tangent theta is equals to m is equals to minus 1. So a theta is equals to minus pi on 4, essentially. But this is not the angle that we are finding. So this angle over here is, so let me just quickly draw a bunch of x's. So theta 45 is this over here. So this is the minus pi on 4, essentially. And we don't quite want that. So we want the angle, we want the angle that's here. So we have to take away. So it will be pi take away pi on 4. So our angle should be 3 pi on 4, right? So this angle over here, okay, I'll remove all of this now, we don't need it. So this angle over here would be 3 pi on 4, okay? So 3 pi on 4. Okay, find the area of the minor segment formed by the intersection of the ray and the circle. Okay, so we are finding this area over here. Okay, we can just use the formula. So area is equals to half radius squared times theta minus sine of the theta. Okay, we know the radius is 2, and it seems like the angle is going to be 90 degrees. Yeah, the angle is pretty much going to be 90 degrees. Okay, so then we'll have half times 2 squared times pi on 2 minus sine pi on 2. Okay, so let's put this on calculator. So we'll have 1 on 2 times 2 squared times by pi on 2, take away sine pi on 2, So the answer, so the area is equals to pi minus 2 units squared. Okay? Right, so a pollutant at time t equals to 0 days begins to enter a pond of still unpolluted water at the rate of this, where V is the volume of pollutant in cubic meters in the pond after t days. The pollutant does not dissolve or mix and spreads across the pond, maintaining the shape of a thin circular disc of radius RT meters and a constant depth of 1 millimeter. What is the maximum rate in cubic meters per day at which the pollutant will enter the pond, and for what value of t will this rate occur? Okay, so we just have to do double derivative here. So we are basically solving for d2v dt squared equals to 0, because we are finding the maximum, maximum of the rate of the change. So we have to differentiate the rate of the change function, which is given to us, and then set it equals to 0. So let's do that on calculator. So I'll remove all of this. Actually, I'll keep this, and then we'll go to insert another problem. Okay, so menu for 1, t 8 times t divided by 240 plus 5 times t to the power 4. Okay, solve that is equals to 0, x, t. So t equals to -2 or t equals to 2. Well, t can't be -2 because t is a time. So t has to be +2. And we have to also find the maximum rate, basically. So our t is equals to 2, and to find the maximum rate, we have to substitute that back into dv dt function, like that. So let's do this on CAS now again. So we'll have this, substitute t equals to 2, so 1 on 20. So 1 on 20 cubic meters per day. Make sure you include the units for all for the rate of the change questions all the time. They're always required. Okay. So at what rate is the radius of the disk increasing after 4 days, where it may be assumed that the radius of the disk is 6.54? Give your answer in meters per day, correct to 2 decimal places. Okay, so we are asked to indirectly find dr dt, which we can find by doing dv dt, which is given, times by dr dv. Okay, how do we find dr dv? Okay, well, they've given us an information that the depth is 1 millimeter. So if I were to draw a cylinder, okay, maybe I'll try one more time. Whatever, this will do. So they're basically saying that this over here is the depth, which is height, is 1 millimeter. Or we can say 0.001 meters. Okay? And we know that the formula to calculate the volume of cylinder is equals to pi r squared h. And we are given our h to be, so v is equals to pi r squared times 0.01. Oh, 0.001. Okay? Now here we can find dv/dr and we can proceed that way. So let's do this on CAS now. So 1 divided by 1000, just going to make sure my unit conversion is correct. Cool. And now pi times r squared times this is our volume at the moment, and differentiate that. So menu for 1 dr, so we get pi r on 500. So dv dr is equals to pi r, sorry, pi r on 500. And we are also given, so dv dr, given that our radius is 6.54, we have, so if I were to substitute r equals to 6.54, okay, so I get 327 pi divided by 25,000. Now to obtain dr dv, we just have to flip it. So a dr dv would be 25,000 divided by 327 pi. Okay? And now we'll just substitute that back into our equation. So dr dt is equals to, what's our dv dt? So 8t divided by 240 plus 5 times t to the power of 4 and times it by 25,000 divided by 327 pi. Okay? And we have to substitute in t is equals to 4 is what we have to substitute in. Okay, so let's do this on CAS now. So 1 divided by the whole thing, like that. So that's done. And now we have to bring this down again, times it by this, and substitute t is equals to 4. So our answer is 0.51. Okay. So that is equals to 0.51 512. How many? Oh, 2 decimal places. What? 2 decimal places. Okay, and what's the units? Meters per day. So meters per day. Okay? Alright, so next question. So use substitution. U equals to square root of 5t squared to express this as an integral involving only the variable u. Okay, so u is equals to square root of 5t squared. So du dt is equals to what is the differential? So if I were to differentiate this, t square root of 5 times t squared, so 2 root 5t. So it will be 2 square root of 5t. So what du is equals to 2 root 5 t dt. Okay, what is this line? So like, this one is pretty easy to make it in terms of u, that's not a problem. Or we can use this information over here actually. So we'll have, if we were to solve for t dt is equals to du on 2 root 5. So now what I can do is, we can put integral of 8 times, no, not times, that is illegal, 240 plus 5 u squared and then times it by, or maybe not times, so du on 2 root 5. So now if I were to cancel this, so we'll get like 1 on root 5 integral 4 on 240 plus 5 u squared. 5 u squared du. Okay, that should be good. Hence or otherwise, find in terms of T the total volume V meter cubed of the pollutant has entered in the pond after T days. Okay, so it's just 1 mark. We don't have to show our working out. So I'm just going to use the equation that they gave, which is the one which is here. Just integrate that from 0 to t, because in case if I made a mistake here and if I use u, then I'll make a mistake in this part here as well. So best to use the information that is already given in the question so that we don't lose all the mark just because of one silly mistake, right? So let's do this question on CAS now. So again, I'll need menu 4.3 from 0 all the way to t, and where is my things? There we go. So this is what we need. So Control C and Control V, T. Okay, so this is the desired output that we get. So root 3 on 15, tan inverse of root 3 t squared on 12. Okay? But we need it in the form of this over here. So I guess we should rationalize. No, it's already rationalized. We might have to undo the rationalization. So root 3 times root 3 divided by 15 root 3 tan inverse of root 3 times root 3 t squared divided by 12 root 3, and that will give us 1 on 5 root 3 tan inverse of t squared on 4 root 3. Okay, so yeah, that should be all good. Okay, what surface area of the pond would the coverage of the pollutant approach? Give your answer in square meters correct to 2 decimal places. Okay, so, well, I mean that we know that V is equals to pi r squared h, the volume of the cylinder, and we also found V in terms of T. So if we could somehow find the limiting value of Vt then we can easily calculate this, because h is given, pi is a constant, so we just have to find the R value, and then we can solve for the surface area. So let's do this on CAS. Okay, so I'll put a limit and see what it approaches to. So here we go limit, and then we go t approaches to infinity, and we put this thing, come on, there we go, here. So it approaches to root 3 pi on 30. So let's write that down real quick. So limit as t approaches to infinity of the whole thing that we just found here. Copy and paste. Okay, so our answer we get is root 3 pi on 30. So that means pi r squared h will approach root 3 pi on 30. So pi and pi will cancel out. R squared is just root 3 on 30 times 0.001. Again, solving this on calculator. So divide by pi. Okay, now times by 0.001. So 57.735. Okay, so r squared is equals to 57.735. So r value is equals to square. Oh wait, we actually don't need to find r value, because our surface area is equals to pi r squared. So we can just use pi times 57.735, because we already have the r squared value that we found. Okay, so that's good. So let's calculate that. So times by pi. So 181.38. So surface area 181.38, and 2 decimal places. And what is the units? Meter squared. Okay. So the cleanup of the pond begins after 5 days, where the pollutant is removed at a constant rate of 0.05 cubic meters per day until the pond is free of pollutant. However, efforts to maintain the flow are unsuccessful, and the pollutant continues to enter the pond at a rate of this. After how many days from the start of the cleanup will the pond be free of the pollutant? Give your answers in day, correct to 1 decimal place. Okay, so a v of t is, I'll just paste it again, just that. Okay, so if that's the case, what is the volume of pollutant after 5 days? Because that's when the cleanup begins, right? So if I do v of 5, let me put that in. So t equals to 5. So 0.150 meter cubed. So after 5 days, this is the volume of pollutant in the lake or pond. So in that case, our new dV/dt would be (8t on 240 plus 5t to the power of 4), because it continues to enter the pond at this rate anyway, and then we have to take away 0.05, because that's the meters per day. So that is the cleanup, basically. Okay. Although this is our dV/dt after, so after t equals to 5 days, basically. And we want to find what, after how many days will the pond be pollutant free. So we want to set 5 to t, because this is the function after 5 days, right? So we have to go from 5 all the way to t, which is what we are finding, so that pollutant will be free. dV Or maybe I'll just write the whole thing down. So it will be that dt little plus the volume, like the volume of pollutant when the cleaning just started. So 0.150. And that all of that has to be equal to 0. And this should give us the answer, basically. Right? I guess we can solve for the value of t then by using this integral. So we'll have, where is our value? There we go. Okay, copy that down. Then take away 0.05 dt. Maybe I'll add a solve. So solve the whole thing plus that has to equal to 0 for my t. Okay. So a t is 6.2. Oh wait, no. This is meant to be from 5, not 0. What am I doing? Yeah, this is meant to be from 5. Okay, so t is 8.40. Okay, so a t value is equals to 8.40 days. Okay? So after how many days from the start of... Oh, from the start of cleanup. So if it's from the start of cleanup, we have to take away 5 from it. So never mind, this is not our answer. So our t that we found was 8.4. And then final answer is going to be 8.4 take away 5. Because that's when the cleanup started to happen after 5 days. So take away 5. Take away 5. So 3.40. So that is 3.40. What's the decimal place? 1 decimal place. 3.4 days. Okay? Alright, so let's move on to the next question. So a model yacht is sailing on the lake between two this. Okay, its path from one buoy to the other relative to origin is given by this. Okay. Displacement components are measured in meters and time t is measured in minutes. Okay. Use a trigonometric identity to show that the Cartesian equation of the path is given by this. Okay, so we can use the second 10. So we got x is equals to 3 sec t. So our sec t is equals to x on 3. Now y is equals to 2 tan of t. So a tan of t is equals to y on 2. And from the formula sheet that you already have, we can grab the identity that sec squared t minus tan squared of t is equals to 1. So x squared on 9 minus y squared on 2 is equals to 1. Okay, as required. Alright, so sketch the path of the yacht on the axis below. Label the endpoints with their coordinates and show the direction of the motion. Okay. So in that case, let's do this on CAS so we can graph this. So Control I2. And if I do graph entry edit and we do parametric. Okay, so our x component was 3 times sec t. And our y was 2 times tangent of t. And our domain is 2 pi on 3. So 2 pi on 3 to 4 pi on 3. 4 pi on 3. Okay, cool. Alright, so this is our graph. And how do I know the motion? So trace path to plot. Okay, so that is your motion. Pretty cool. Alright, pause. Okay, what is the starting value? So 6 and minus 3.46. Okay, so minus 3.46, so like somewhere here, and 6, so like, so 1, 2, that's 3, that's 3.5, so somewhere here is the starting value. And our axis intercept, let's see what that is. It's -3 is our x-intercept. Continue the animation. So -6 and 3.46. So -6 and 3.46. So here. Okay. Okay, and we show the motion, it's going this way. And so our point here is -3 and 0. Okay, so that's that. Oh, and we have to label the endpoints as well. So I assume that the endpoints is the actual domain. So sec 2 pi over 3 minus 6. Okay, and then if I do tangent, minus that, which is that. Okay, cool. So our endpoint, so 2 pi on 3 would be both of them negative. So it will be -6, comma, -2√3. And the other thing that we have to label is the other one. So 4 pi on 3, 4 pi on 3, -6, and 4 pi on 3. That's cool. So -6 to 2√3. Okay, so that is our coordinates. All right. Write down an expression in terms of t for the square of the speed of the yacht at any time t. So in terms of sec, okay, so in that case we have to define the vector first. So because that's the position vector that we have, and we have to find the velocity vector, and then find the magnitude or the norm of it. So define that. So 3 times sec of t, comma, what was it? Sec and then 2 times tan of t. So that, and if I want to differentiate this, a menu for 1 dt. Okay, let's find the norm. So norm this. Okay, so this is our velocity, or maybe the speed vector, whatever you want to say, like velocity technically. Okay, so we have to square it as well. So let's square that. So square. Okay, so this should be our squared equation. So s squared of t is equal to 9 sine squared t plus 4 divided by cosine to the power of 4 t. And we want the expression to be in terms of sec. So we know that sec is equals to 1 on cos. Okay, so we'll go with that. So we can say that this is sec squared, right? So we'll have 9, or maybe should save some space. So 9 sine squared t times by sec squared t. Okay, and we can also use the identity that sine squared plus cosine squared is equal to 1. So sine squared equals to 1 minus cosine squared. So you can write that down. So 9 times 1 minus cosine squared t times by sec squared t. Okay. Oh wait, I'm forgetting the plus 4. Okay, plus 4 times by sec squared t. Okay, that should be good. Wait, no, it should be to the power of 4. I'm making a lot of mistakes. Yeah, so sec is 1 on cosine. Yeah, it should be sec to the power of 4. I don't know why did I think it's squared. Okay, anyway, I think that should be good. And now, yeah, as I said, we can use the identity. So 9 times 1 minus cosine squared of t plus 4. Okay, times sec to the power of 4t. Okay, so then this will have 9, to change that, so 9 times 1 minus 1 on sec squared of t plus 4 sec to the power of 4t. Okay. And the bracket is at the wrong place, just noticed. Plus 4. Okay, that looks good. Alright, so it will be 9 minus 9 on sec squared on t plus 4 times by that. Okay, so we'll have 13 minus 9 on sec squared of t times by that. So this will simplify to x squared of t is equal to 13 sec to the power of 4t, take away 9 sec squared t. Okay, that should be good for the speed. Okay, so find the time in t minutes when the minimum speed occurs. You do not need to justify that this is the minimum speed. Okay, so let's differentiate the speed function first and then set it equal to 0. So we'll have mu for 1 dt, differentiate that and solve for this equals to 0 comma t, and our t has to be between 2 pi on 3 and 4 pi on 3, right? 3. Oh, wait. So t equals to pi. So t is equals to pi minutes. State the minimum speed of the yacht in meters per minute. Okay, so we'll just substitute that back in the speed function, which is that. So 2. So 2 meters per minute. Okay, state the coordinates of the yacht when the minimum speed occurs. So we need the position vector again. Okay, there, up to t equals to pi. So that are the coordinates. So minus 3 and 0. Okay, that should be good. Let's move on to the next one. So write down a definite integral in terms of t that gives the distance traveled by the yacht along the path given by this, or the time interval that. Okay, so it's just asking for the arc length, not too hard. So it will be 2 pi on 3 to 4 pi on 3. We need to differentiate, so let's do that. Okay, so for 1 dt. Okay, so it will be dx dt squared, so 3 sine t of cosine t squared whole squared plus 2 on cosine squared t squared. Okay, find the distance traveled by the yacht over this time interval. Cool, so let's set up the integral. So menu for 1, menu for 3, 2 pi on 3 to 4 pi on 3, square root, maybe I should really type that down, square root of square brackets this squared plus this squared dt. So 9.4 meters, so 1 decimal place. Okay, cool. The position vector of a drone videoing the yacht relative to the same origin as the yacht O is given by this. Displacement components are measured in meters and time t is measured in minutes. Okay, what is the shortest distance from the drone to the yacht as the yacht sails along the path given by this? Okay, so we are basically finding d dt of magnitude of rd of t, take away ry of t, that has to be equal to 0. Okay, and yeah, I guess let's just solve this. So let's define everything again. So our vectors are 2 minus 3 times t, take comma 4 times t minus 1, 6 minus t. Okay, and now we have to define the drone one again. So 3 times sec of t, 2 times tan of t, and 0. Yeah, the only reason why we had to define the drone vector again is because I didn't have the k component, so yeah. Okay, now we have to do norm. So norm of this minus that. Okay, and then we have to differentiate that. So menu for 1, that looks pretty big, like the equation. Okay, now if I do solve that equals to 0 comma t, and our t is between 2 pi on 3 less than or equals to t less than or equals to 4 pi on 3. Okay, right. So we get 2 of these values. So which one do we take? So let's put this over here first. 11 point that. Okay. Now let's put this one. 14. So I guess we just take the 11 one. So t is equals to, what was the value of t? So 2.34 minutes, and rd of t, take away ry of t, magnitude, given that t is equals to 2.34, and that has to be equals to 11.1 meter. Okay, so next question number 5. So if consider the points a, b, find the vector equation in terms of I, j, and k for the line passing through these points. Okay, pretty simple. So we'll just take I minus 2j plus 3k plus, we have to find the vector from b to a. or A to B, whatever. So let's add a new problem. So document, insert a new problem. Okay, so define A to be 1 comma minus 2 comma 3. Okay, and then define B to be 2 comma minus 5 comma minus 1. Okay, and now we just have to find B minus A or A minus B, whatever, doesn't matter. So we'll just go with B minus A. So that will be T times I minus 3J minus 4K. And of course, do not forget to write the domain for T, or else you won't get the mark, okay? Consider a different line this, okay? Find the shortest distance from L1 to point A. Give your answer in the form of this. Okay, so if I were to draw this stuff out, so let's say I have a line, this, okay? So this is my L1. And let's say that this is my point A. Okay? And I want to find the minimum distance, basically. So minimum distance occurs when these two are perpendicular to each other, right? So in that case, we have to find, so let's say that this intersect at point B. No, point B is used. Maybe I'll say point X, for example. Okay? So in that case, we first have to find the vector from A to X, and then we have to do dot product of the vector AX and the directional vector, which is this one, and set it equals to 0, because that's when the lines are perpendicular, right? So if the dot product is 0, that's when the lines are perpendicular. So let's find X first. So what is our X? X would be 2 minus T, comma, will be 1 plus 2T, and then we have minus 3 plus T, right? So this is just X with respect to T, and maybe I'll just say T belongs to R, just so that I don't get a mark off for the domain, okay? And our A was, what was A? 1, negative 2, and 3. So 1, negative 2, and 3. So now if I were to find the vector AX, let's do this on CAS. So 2 minus T, comma, 1 plus 2 times T, comma, minus 3 plus T, okay? So let's do the dot product. So dot P, oh wait, no, we have to find the vector A to X. So A take away that. Actually, we have to do final minus initial. So X take away A. So it will be 1 minus Ti plus 2T plus 3J plus T minus 6K. Okay, so that should be our A to X vector. So what I meant by saying was, why do we have X take away A and not the other way around? Because we are going from A to X, right? So final minus initial. Okay, that's the logic, right? And now we have to find the dot product between AX and the directional vector here. So AX dot product, what is it? So negative I plus 2J plus K has to be 0. Okay, so we'll have solve and then dot P of that, comma, negative 1, comma, 2, comma, 1. That has to be equal to 0, comma, T. So a T is 1 on 6. So a T is 1 on 6. And to find the shortest distance, we have to find the magnitude of ax first, and then we have to substitute t equals to 1 and 6 in there, right? Because that's how we find the shortest distance. So norm of this, okay, and now I substitute in t. So 5, so that will be 5 root 66 on 6 units. Okay, yeah, okay, so in the form of a square root of b on c. So that looks correct, the form is correct, so I'm gonna say that the answer is correct as well, hopefully. Okay, so next question. Find the Cartesian equation of the plane that contains points A, B, and C. Okay, so first I'm going to define point C. So define C equals to 0, 2, minus 5. Okay. Now to find the Cartesian equation of the plane, we can do n vector. Yeah, n vector equals to BA cross BC. Okay. And oh, 3 marks. Okay, maybe what I'll do is I'll just write the vectors down as well, just to show my working out. So BC, and then I'll write N here, so that, yeah, I don't lose mark for working out, in case if there are marks allocated. Okay, so in that case, so let's do from vector B to A. So final minus initial, so A minus B is that. And then C minus B is that. Now we'll do cross P of these two vectors, BA and this one. So this is our cross product. And now I'll just copy all of this down. So BA we found to be minus I plus 3J plus 4K. And this we found to be minus 2i plus 7j minus 4k. Okay, and our n vector was negative 40i minus 12j minus k. So our equation of the plane would be minus 40x minus 12y minus z is equals to d, and we can just simply substitute a, b, or c into this equation to find the value of d. Okay, so we'll get, let's substitute maybe c, so add 0, 2 and minus 5. Okay, so well, that's a weird line, there we go. So this would basically give us minus 24 plus 5 is equals to d. So d is just negative 19. So our equation of the plane is going to be minus 40x minus 12y minus z is equals to minus 19. Maybe I should multiply by negative 1 as well. So that is equals to 40x plus 12y plus z is equals to 19. Okay, that's that. So another plane has Cartesian equation 2x minus 3y plus 4z equals to 12. This plane intersects the coordinate axis at 3 points, which form the vertices of a triangle. Okay, so find the coordinates of these 3 points. Alright, so in that case, if I were to draw this one out like that, so let's say this is my y, this is my x, and this is my z-axis, okay? Now, the plane intersects the coordinate axis at 3 points. So that means if the plane is intersecting at y, it will be on the y-axis, which would mean that x and z would be 0 at that point, right? Same applies to the x. So if the plane is intersecting at x, it will only intersect at x-axis, meaning that y and z would be 0. So to find the coordinates, if we are finding the x coordinate, we have to set y and z equals to 0. So x coordinate can be determined by 2x is equals to 12, which implies that x is equals to 6. So one coordinate is going to be 6, 0, and 0. So minus 3y is equals to 12, which implies that y equals to minus 4, which implies that 0 minus 4 and 0. 4z is equals to 12, which implies that z is equals to 3, which implies that third coordinate would be 0, 0, and 3. Okay? Hopefully that makes sense. So find the area of the triangle, give your answer in the form of m root n. Okay, well, we can just use the formula here. So we can just use the cross product formula to find the area of the triangle. So first, let's find the actual vectors that we can use to find the cross product. So it will be 6, 0, 0, and take away 0, minus 4, 0, which is equals to 6, minus 4 and 0. This will be 6, 0, 0, take away 0, 0, 3. So this will be 6, 0, minus 3. Okay. Oh wait, actually this should be plus, not minus. Okay. I think that should be good. Alright, now we can use the formula to calculate the area. So area is equals to half times the magnitudes of 6i plus 4j plus 0k cross 6i plus 0j minus 3k. Okay, let's do this on CAS. So just to make sure I've done everything correctly, I'm just gonna do 6, 0 minus 0, take away minus 4, 0. Okay, that's good. And the last one, which is 3, this one would be 0. That's all good as well. Now we do cross product. So cross product, that and that. And now we find the magnitude. So norm and divided by 2. So 3 root 29 should be our answer for this. So that would be half times 6 root 29, and that is going to be 3 root 29 unit squared. Okay, that's that for question number 5. So let's move on to question 6. Okay, a machine fills bottle with olive oil. The volume of olive oil is dispensed into each bottle may be assumed to be normally distributed with the mean mu milliliters and standard deviation 4.2 ml. When the machine is working properly, mu is 1000. Okay, the volume dispensed is monitored regularly by taking a random sample of 9 bottles and finding the mean volume dispensed. Okay, the machine will be paused and adjusted if the mean volume of olive oil in the 9 bottles is significantly less than 1000 ml at the rate of 5% level of significance. When checked, a random sample of 9 bottles gave a mean volume of this. Okay, a one-sided statistical test is to be performed. Okay, write down a suitable null and alternative hypothesis. So that would be H0 is mu equals to 1000 ml and H1 is mu is less than 1000 ml. Okay, find the p-value for this test, correct to 3 decimal places. So our p-value is basically calculating the probability that sample mean is less than 997.5 given that mu is equals to 1000. Okay, so let's do this on CAS. Right, so mu 552. So lower bound is that, yep, 997.5 is our upper bound. Our mu is 1000 and standard deviation is 4.2 divided by square root of 9, which is 3. Press enter. So our p-value is equals to 0.037. Using p-value found in part before this one, okay, state with a reason whether machine should be paused. Okay, well, so since p-value is less than 0.05, machine should be paused. Should be paused. Okay, machined. That's not even a word, I believe. Okay, anyway. So, assuming that the mean volume dispensed by the machine each time is in fact 997 ml and not 1000 ml, find the probability of a type 2 error for the test using 9 bottles at 5% level of significance. Assume that the population standard deviation is 4.2 ml and give your answer correct to 2 decimal places. Okay, so first we have to find the critical value for the 5% significance. So let's do this on CAS. So menu 553 and our area is 0.05, our mean is 1000, and standard deviation is 4.2 divided by 3. Okay, so our critical value is equals to 997.697 ml. And to find a type 2 error, which is basically saying probability of not rejecting, do not reject 80 given that mu is 997. Okay, and that is the same as writing sample mean greater than 997.697 given that mu is equals to 997. Okay, now if you want to, maybe I can show you visually as well what area we are finding essentially. So let's say we have our 2 bell curves. Wow, that's a beautiful bell curve. Okay, let me copy and paste another one here. So color, blue, copy and paste. Okay, and let me extend the line. Alright, color to red maybe. Okay, so this will have a mean of 997. Okay, and this will have a mean of 1000 ml. Oh yeah, 1000 ml. Okay, now our critical value, which is 997 point this. Okay, I'm going to say that this is our critical value. Our scaling is quite off here. Okay, this is our critical value, and anything to the right of critical value is do not reject 80, and anything to the left will be reject 80. Okay, and look at what we are finding essentially. So we are basically finding this area over here. So this is our type 2 error. Okay, now of course this diagram and the area might change depending on different scenarios. For this scenario, this is what we have. So this is our type 2 error. Type 2 error. Can't spell error. Okay, there we go. Okay, so let's find this on CAS, shall we? So it will be, just reuse this one over here. So this would become, okay, and this would become that. This would become infinity. There we go. That should give us our answer. Oh, the mean is 997. Okay, so the answer is equals to 0.3, 2 decimal places, so 0.31. Okay, hopefully this made sense. Okay, so let's move on to the next question. Let x bar denote the sample mean of random samples of 9 bottles. As a quality control measure, the machine will be paused if x bar is less than a or if x bar is greater than b. Okay, where PR x bar less than a is this, greater than b is this. Assume that mu is 1000 ml and standard deviation is this: find the value of A and B correct to 1 decimal place. Okay, so this is just a inverse normal question. So menu 553, area is 0.01, mean is 1000, and this is 4.2 divided by 3. Okay, so our A value is equals to 996.7 ml, and our B value, let's find that out, so it should be 0.99, be 1003, so that should be 1003.3 ml. Okay, a new machine is purchased, and it is observed that the volume dispensed by the new machine is in 50 randomly chosen bottles, provided a sample mean of 1005 ml and a sample standard deviation of 4. Okay, so find the confidence interval for the population mean volume dispensed by the new machine. Giving values to correct 1 decimal place, you may assume a population standard deviation of 4 ml. Okay, so again we can do this on CAS. So menu 661, and data input is stats. So our standard deviation is 4. X bar is going to be 1005. Our n is going to be 50, and okay, so this should be our confidence interval. Okay, so 1003.9 to 1006.11. Okay, 40 samples each consisting of 50 randomly chosen bottles are taken, and a 95% confidence interval is calculated for each sample. In how many of these confidence interval would the population mean volume dispensed by the machine expected to lie? 40 samples consisting 50 randomly chosen bottles are taken, 95% confidence interval is calculated. In how many of these confidence interval would the population mean volume dispensed by machine? Oh, that is just 0.95 times 40, not 50. Okay, 40, because we are talking about the sample. Okay, so 40, so 0.95 times 40, 38. So 38. What minimum sample should be used so that with 95% confidence the sample mean is within 1 ml of the population mean volume dispensed by the new machine? Assume a population standard deviation of 4 ml. Okay, so I think this is referring to the marginal error, I believe. And marginal error has a formula of z times s on square root of n. And here we are solving for the sample size, so square root of n is z times s on me. So our n will be z times s over me whole squared. So n is 95% confidence interval, meaning that it's 1.96 times what is our standard deviation? It's 4 divided by 1 squared. Okay, so our n is, let's calculate that. So 1.96 times 4 squared, so that is 61.47. Now sample size should be nearest to whole number, so I'm gonna say n is equals to 62. Okay, yep, that's that for the extended response part of specialist maths. Hopefully you learned a lot from this, and hopefully you guys did well as well. In my feedback, I would say the paper was pretty standard. I would say it wasn't too hard, in my opinion, except the except the first question. This one, it took me a while to get the idea of it, but we still ended up getting it anyway, hopefully. But apart from that, the paper was pretty standard, and yeah, hopefully you guys did well. Okay, that's it for this video. Thank you all for watching, and I'll see you in the next video. Bye bye.